Hey, this is Miss T here to talk to you guys about gas laws. Remember that gases are all around us. Here in this picture, you can see some of the different ways that we have gases in and around. Hey guys, I'm here to talk to you about gas laws. Okay, remember that gases are found all around you. On the screen, you can see some different types of pictures of places where we find gases. For example, gases can be found in the atmosphere on Earth. For example, we have oxygen gas, nitrogen, a little bit of helium, hydrogen, all kinds of gases that can be found in our atmosphere. You can find bubbles in soda. For example, when you drink that Coke or that Dr. Pepper or that Sprite, the bubbles that you see are carbon dioxide bubbles. Natural gases can come from fumes from volcanoes, and the gases can be something as simple as helium and balloons. So we can find gases anywhere around us on Earth. There's a few characteristics of gases. The first one that we've talked about in class, gases can fill any shaped container, no matter what the size or what the shape. Gases are special because they're going to spread out to fill the whole space of that container. So they're not going to sit to one corner or to one side. They'll go and fill up the whole container. Another characteristic is that gases can be compressed. When you think about water, you can't really compress water, but gases, we can squish it down real low, so gases can be compressed. Another one, gases expand when they are heated. So that kind of brings us into the next one. When we heat molecules of gases, they move freely and they have large spaces between them, but especially when we heat them up, they tend to move faster and move even further apart. So again, they can fill any size or any shape container. They can be compressed, they expand when they're heated, and they move about freely and they have large spaces between them. Here's a picture of what a substance would look like as solid, liquid, and gases. As you notice, we have a little Bunsen burner down at the bottom. So the solid molecules are all compact, all close together, and then we're heating them up, and as we heat them up, we move on to a liquid, so that would be a phase change. So we're moving to the liquid. In the liquid phase, you can see that all the liquid molecules are still close to the bottom, but they're a little bit more separated out, so those move somewhat more freely. But as we continue heating, we would eventually get to a gas. Those molecules are really spread apart, and they fill up the whole container, and that is quite different than a liquid and a solid. All right, the first law that we talked about in class was Boyle's law. Remember that Boyle's law is an indirect relationship between pressure and volume. So if you see pressure, you automatically need to think about Boyle's law. Okay, remember pressure and volume. As pressure increases, Boyle's law says that volume should decrease, and then vice versa. As pressure decreases, volume increases. Okay, this is an indirect relationship. It's indirect because as one goes up, the other one goes down. Remember, Boyle's law, pressure and volume, as pressure increases, volume decreases. Okay, here is an animation of Boyle's law. As you notice, the pressure changes, and I'll play it again, as we compress the plunger on top. So we add weight to add pressure. As we do that, the pressure increases, and what do you notice happening to the volume? It decreases. Over on the right, you can see the graph that's being formed. So at high pressure, at high volume, we have a very low pressure. And then if we let it go, okay, at a high pressure, we have a lower volume. Okay, so this is just, again, something for you to see. As pressure increases, volume decreases, and again, as volume increases, pressure has to decrease. Okay, a couple of examples of Boyle's law. So these are real-world examples. The first one would be bubbles exhaled by a scuba diver. They grow as they approach the surface of the ocean. So if they're real deep down in the ocean, there's a lot of pressure. As they come up, the pressure is going to decrease and the volume of the gas is going to increase. Another example would be the deep sea fish. They tend to die when you bring them up to the surface for the same reason. Another example, pushing in a plunger of a plunged syringe. So as you push the plunger, pressure increases and the volume air entrapped inside decreases. Another example would be the Cartesian diver that you saw in class. So when we squeeze the Cartesian diver, squeezing caused the pressure to increase and the volume of the gas inside of the diver decreased. So those are examples of Boyle's law. Okay, moving on to Charles' law. Charles' law is a direct relationship between temperature and volume. So if you see temperature, you automatically think Charles. Again, remember, pressure is Boyle's law, temperature is Charles' law. All right, with temperature and volume, as temperature increases, volume will also increase. Vice versa, as temperature decreases, volume decreases. Again, this is a direct relationship because as one goes up, the other one goes up as well. And if one goes down, the other one goes down. Okay, here is a simulation of temperature and pressure. So as you watch, we increase the temperature and the volume increases. We increase the temperature, volume increases. You can see the graph on the side. As volume goes up, temperature is going to go up. So this is going to be a straight line. Okay. Vice versa, when we take the temperature away, the volume goes back down. Okay, some examples of Charles' law. Example, a football is inflated inside. So inside we would be a little bit warmer. And then if we take it outside on a cold winter day, it's going to shrink slightly. A slightly underflated rubber life raft left in a bright sunlight swells up. This can also kind of relate to swimming pool floats. Okay, if it's hot outside and in the direct sunlight, it's going to swell up even more. But if we were to take that same swimming float and it'd be wintertime, it would shrink up. Another example would be hot air balloons. We talked about this in class, but with hot air balloons, as you increase the temperature, the volume of the balloon is going to increase. And also we know that heat rises, which causes the balloons to rise. And that's all that I have for you guys. If you have any questions, please ask your teacher.